Hello, this time we're going to look at something that's a little bit different to what we've been doing before. So we've been looking at integrals, we know how to do that, but what we've been doing is doing definite integrals, where we've known the parameters on each side. But what if we don't? What if we want to go from 2, but we also want to go to infinity? So we know that we have exponential graphs. So, sometimes we might have a graph that does something like this. Hopefully you remember that there's things called asymptotes, and there are graphs that approach asymptotes and never actually touch them. They could look more like this, they could look more like this. We know that they can look lots of different ways, but there are ways that we can use infinite limits in our integrals. So that's what we're going to do here. How do we find the area of this graph between 2 and infinity? So there's a relatively easy way for us to do this. So the first thing I'm going to do is just replace infinity with any sort of letter. I'm just going to use the letter M. You could use anything you want. I suggest not using X because we already have, X's and Y's all over the place. So try and pick a different letter. You can use whatever you want. M, T, who cares? So I'm going to go between M and 2, and then I'm just going to rewrite this to the -4 because obviously that's how we integrate. So I'm just going to use the letter M when I'm doing this. All right, so the first thing I'm going to do is actually do my integration. So 3x, add 1 to the power, divide by the new power. That's nice and easy, and it's going to give us -1 over x cubed. Obviously, this is going to be -1x to the power of -3, which turns into this. All right, so what do I do now? Now I can't just substitute the two letters, so the two numbers in like we normally do, because I've got a letter up here. So what you need to do is actually have a bit of a think about this. So let's move up here so I don't have to move screens. So instead of putting my top number in here, I'm going to use the letter. So I have my first one minus my second one, and my second letter is 2 cubed. All right, now I want you to have a think about what happens here. If you can't just make some assessments about what happens with the numbers, you can do some testing. So we are approaching infinity. So what happens as m gets bigger and bigger and bigger? Does it approach 0 or does it approach infinity? So if you can't figure out what that is, let's do a bit of testing. So if we did -1 over 2 cubed, right? That would give us -1 over 8. What if we had -1 over 3 cubed? That would give us -1 over 27. What if we had -1 over 10 cubed? That would give us -1 over 1,000. So what is happening here? Is the number getting bigger or smaller? Well, hopefully you can see the number is getting smaller. So that means as m approaches infinity, as m gets bigger and bigger and bigger, this fraction is approaching 0. It's never going to get to 0, but it is forever approaching 0. So what we say, I'm going to get rid of all of this because it's now all in my way. So as m approaches infinity, so as m approaches infinity, that means that -1 over m cubed is approaching 0, which means this is essentially 0. If we take it to infinity, we can say it is basically 0. So now I have, let's just put a little bubble around that. So that means this is going to be 0 minus -1/8. So then this obviously becomes plus because we've got minus -1/8. So we have 0 plus 1/8, which is 1/8. So that is our final answer. That means the space under this curve, as it goes from 2 to infinity, is 1/8. All right, I'm going to save this and I'm going to do another example. All right, let's have another look. All right, this time I'm given the function y equals 1 over x minus, whoops, nope, I've written that wrong, 1 minus x cubed. All right, so the first thing I'm going to do is just rewrite it. So then I've got 1 minus x to the power of -3. Okay, so what I want to do now is I want to integrate this between 0 and negative infinity. So sometimes you can have positive infinity and negative infinity. So I am going to find the integral of 1 minus x to the power of -3 with respect to x. So again, I'm going to replace this with a letter. I'm going to use m again, but you can use any letter you like. So between 0 and m, I want to find the space under this curve between those two values. All right, so I'm going to do exactly what I did before. The first thing I'm going to do is integrate. So I've got 1 minus x. I'm going to add 1 to the power and divide by the new power. Now, hopefully you've recognized that this is the chain rule. We have two different things in the brackets, so I need to divide by the derivative of the brackets as well, which you should be able to see as -1. So if I just rewrite this, let's again just move up here. So if I rewrite this, I've got 1 minus x all to the power of -2, and -2 times -1 is just 2. And so again, we need to rewrite this because we have a negative power, so this becomes 1 over 2, 1 minus x squared. So that is our lovely integration. Now what we need to do is substitute in our numbers. So if I substitute in 0 and m, so I get 1 over 2, 1 minus 0 squared minus 1 over 2, 1 minus m squared. And again, this is where you need to use a little bit of intuition. So 1 minus 0 is 1, 1 squared is 1, so this is just half. So then what we need to do is figure out what's going on here. So again, you need to think about when you increase the number m, decrease the number m, because we are going to negative infinity, aren't we? You need to think about what happens. So as we change this number, what happens to this fraction? And again, you can try different numbers. So if you can't see what it is, great, just put in some numbers. So let's start with 10. All right, so if I have 1 over, so 2 times 1 minus 10 is 9, 9 squared is 81, 2 times 81 is 162, all right? And let's make this smaller now. So 1 over 2, 1 minus 2 squared. So this is now 1 over 1 minus 2 is -1, so that is half. Did this number become bigger or smaller? You really don't need to keep testing numbers. Just pick 2, see if it tends towards 0, or see if it tends towards infinity. This is obviously getting bigger, but hopefully you can see this number is never going to become less than 0, because anything that happens here, so for example, I will just put in a negative number to show you what happens. 1 minus, and this becomes -3, let's say. Because I'm squaring it, it's going to be positive again. So if I have 1 over 2, 1 minus -3, which is 1 plus 3, which is 4. Well, I haven't got enough brackets around that. So this is now 4 squared, which is 16. 2 times 16 is 32. So you can see that this is going to be approaching 0. So that means, so we're never getting to 0. This means that obviously, I mean, you can't, you've got asymptotes, right? You should be able to tell what number you put in here to make it. Anyway, don't worry about that. The whole point is what happens here. So this is 0, which means, again, I'm going to just get rid of that because we need more space. So we've got 1 minus, half minus 0, which is just half. Wow, that does not look like a 2. Half. So this is the area under this curve between 0 and negative infinity. Now, if it helps you to picture graphs, then that's fine. What this graph is, it sort of looks like this, right? It goes up like that. It's a thing. So what we're doing is we're trying to find the area between 0 and some point. And you can see here what's going on. Anyway, I'm not going to go into all the graphing stuff, but that's basically what we're doing here. All right, let's do one more example. All right, so there is something slightly different that can happen here as well. So there's a different version of this, and the other version of this is when there is no definite answer. So you can also have versions of this where either you're being asked to prove that there is an answer or you're being asked to show whether there is an answer. So I'm going to do two of the questions from the book now. This is question 1B. I have not assigned these questions to you, so I'm just going to do two of the questions. So we're being asked to integrate between infinity and 4 of 4 over x to the power of 5 with respect to x. All right, so let's do this. So again, I'm just going to rewrite this, of course. So infinity to 4 times x to the power of -5 with respect to x. So let's integrate now, change the power, add 1, divide by the new power, which gives us negative x to the power of -4, which gives us -1 over x to the power of 4. All right, so this is our integral. So now what we're going to do is say what happens when we plug in these values. So I have, I'm starting with infinity. So I'm just going to use m. So instead of my infinity sign, let's just fix that over here. I'm going to use m. So then I'm going to have -1 over m to the power of 4 minus -1 over 4 to the power of 4. So what happens here? As I put numbers in here, as they get higher and higher and higher, is my fraction going to get bigger or smaller? Well, this is a -1, and as I put higher and higher numbers in here, hopefully you can see that this is -1 over 256, so I just put that in there. But this here is -1 over 1 to the power of 4, which is just -1. What if I have -1 over 2 to the power of 4? I have -1 over 16. This number is clearly much smaller than this number. I am always going to be getting closer and closer to 0. I'm starting from -1, closer and closer to 0 without ever actually hitting 0. So if I have -1 over 3 to the power of 4, right? You can see that I've got -1 over 81 now. I'm getting closer and closer to 0. I'm never going to hit it, but that means this is the approximate sum of moving towards 0 the closer we get. So now I have 0 minus negative, right? So this is now 0 plus 1 over 256. So my answer is 1 over 256.